Welcome. In this tutorial, running an exercise, your learning goals are to identify the purpose of different types of exercises. Choose run versus test. Observe process component failures and simulated faults. Identify visual and audio indications of an alarm. Acknowledge alarms and end an exercise.
Types of exercises. To get an exercise started, we log on as an operator and select the process model for SPM 700. Simtronics ships each process model with a minimum of 3 exercises. They differ in either the initial conditions, or in what happens after the simulation starts. First, there is the design exercise, which has 3 purposes. 1. It enables operators to study the normal operating conditions of the process. The initial conditions set all process variables at design specifications. The simulation would run smoothly forever, at design conditions. 2. The design exercise is used to practice the shutdown procedure. Three. The design exercise provides a baseline for creating exercises with faults that must be handled by the operator. Next is the cold start exercise. Here the initial conditions set all process variables to 0. You can study and practice process startup and shutdown using this exercise. The SPM 700 training manual, available from the Help menu, contains the startup and shutdown procedures recommended by Simtronics. Next are the fault exercises, without titles. They contain equipment and instrument failures. The title of the exercise is hidden from an operator or technician, so they don't know what to expect. Exercises that ship with the DSS 100 software have explanations in the instructor manual. Normally, between 1 to 2 minutes into the simulation, a pump, or a temperature sensor, or some other indicator or controller, will fail. The failure may be sudden, or in stages. Just like real equipment. The point of the exercise is for the operator to recognize the problem and take corrective action to minimize the damage or cost. Responding to alarms will be covered in detail later in this tutorial. You may also see instructor-created exercises. These contain equipment failures requiring procedures that apply at your worksite. They are normally used in a training course designed for your particular process equipment operations. Here we select the design exercise. Choosing run versus test. When starting a DSS 100 session, your next decision is whether to run or to test. You should be aware that the DSS 100 software saves all session data of operators and technicians. In most cases you will click Run. The selected exercise of the process simulation runs for study and practice. Your instructor may request that you click Test when you feel you have mastered a fault exercise. The only difference is that the session data is flagged as a test for the instructor. The simulator operation and exercise execution is otherwise the same. Process component failures and simulated faults. In some exercises, simulated components develop a fault or failure. All exercises, except those based on cold start, initialize the SPM 700 to design specifications. You can check what these are by consulting the normal operations page of the SPM 700 operator training manual. Starting with design conditions, the operator may simulate faults by shutting down equipment or changing process variables. Detailed methods of controlling the simulation are demonstrated and explained in later tutorial lessons. Any controller or equipment may be set to fault in a pre-programmed exercise. You may need to use different simulator categories, such as trend, to analyze what has faulted and how to fix it. Later tutorials describe these categories in detail. Failures and faults cause the process variables to depart from design conditions when they vary too much. Alarms are set to alert the operator. Let's examine alarms. Alarm indications. Before we discuss alarms, become familiar with the SPM 700 overview schematic. You may roll over any instrument for more information about process variable operating limits. When a process variable drops below or rises above its defined alarm limit, an alarm is triggered. The operator must acknowledge the alarm and get the process variable back within limits and return the process to stable operation. As a demonstration, the set point of controller FIC 101 is ramped down to 150 gallons per minute. The alarm is automatically acknowledged and silenced because the loop is currently selected from the schematic. The process variable also changes color to indicate that the loop is in alarm. An alarm sounds briefly when the process variable drops below its low alarm limit of 200. Notice that the bottom's product flow indicator drops below its low alarm limit. Methods of acknowledging alarms. The alarm is set and sounded. The process variable will flash until the alarm is acknowledged. You can acknowledge the alarm by selecting the digital value here. If there are many alarms, you may want to view the alarm summary page. View the alarm summary page by selecting the alarm button from the toolbar. The alarm summary page displays all the current alarms. Acknowledged alarms are steady and unacknowledged alarms are flashing. To acknowledge the bottom's product alarm, click anywhere on its listed entry. The alarm is silenced and its color is now a steady dark blue. Blue indicates a low alarm. Red indicates a high alarm. This color coding is used on all other displays as well. Roll over highlight boxes for more information. Notice what happens if you click on the instrument tag ID. Users granted the access level of operator are directed to the first group display that contains this loop. All other users will see the loop's detail display. In both cases the alarm is still acknowledged. The overview display identifies all the groups. The same scheme to identify loops in alarm is used to identify any group with a loop in alarm. If the alarm is unacknowledged, the group ID and group number are flashing. If the alarm is acknowledged, the group ID and number are a steady alarm color, depending on the direction. The group display shows the faceplates of all the loops in this group. It also shows which loops are in alarm. Simply click anywhere on a faceplate to acknowledge its alarm. When you end a fault exercise, both your actions and the final conditions are important. Simply acknowledging an alarm does not fix the problem. Ending an exercise. The type of exercise you are running matters. An instrument in alarm indicates that there is a deviation in the process. A swift response to an alarm can prevent an upset condition from occurring. Responding directly to a key process variable that is in alarm may not always be the best corrective action. Understanding and observing the relationships of all process variables can help you troubleshoot the problem and take proper corrective action to return the process to design conditions. For example, reboiler fouling might be the cause of column temperature, pressure, composition, product flow rate, and level alarms. Condenser cooling water fluctuations could cause column temperature, pressure, composition, flow rate, and level alarms. Troubleshoot the conditions, identify the fault and make adjustments to restore operation. You may need to assume manual control, or conduct an emergency shutdown if a critical situation cannot be handled quickly. The SPM 700 Operator Training Manual contains the emergency shutdown procedure recommended by Simtronics. When you are done, exit the simulation and your results are saved. The event log, the notepad, and the final conditions of your run are all saved. Your instructor can now review the session,